Air Conditioning and Refrigeration Video Lecture. The four essential elements in the refrigerating device are compression, condensation, expansion, and evaporation. First is the compression stage. The refrigerant vapor is compressed in the compressor at this stage. This stage can be considered different depending on the entrance or exit of the heat. In general, the stage is assumed as an adiabatic compression stage. The pressure changes along the isentropic line and arrives at the condensation pressure. The refrigerant gas charged to the compressor is compressed at high temperature and high pressure by the piston in the cylinder. The compression stage is increasing the pressure so that the condensation can be done better through the cooling by water or air at room temperature. In the condensation stage, the refrigerant is condensed in the condenser. The refrigerant is condensed by the water or air at the outside of condenser. It changes from gas to liquid at low temperature and high pressure. The high-pressure refrigerant gas from the compressor can be easily liquefied by the cooling water or cooling air at room temperature. The condensation heat is the heat discharged to the cooling water or cooling air at this time. The condensation heat is the sum of the heat absorbed by the refrigerant from the evaporator and the heat applied during the compression in the compressor. The expansion stage is the state change of refrigerant when it passes through the expansion valve. There is no change in enthalpy since it is also an adiabatic expansion without entrance or exit of heat with outside. This expansion stage decreases the pressure so that the condensed refrigerant liquid in the condenser can evaporate easily in the evaporator. The temperature also decreases during the expansion stage. The expansion valve is the place where the refrigerant expands. The expansion valve decreases the pressure and controls the refrigerant flow rate charged to the evaporator. In the evaporation stage, the liquid refrigerant evaporates in the evaporator of refrigerating device by absorbing the evaporation latent heat required for the evaporation from the material or air around the cooling pipe. The air or material that had been deprived of the heat by the refrigerant stays at low temperature, and the refrigerant evaporates by taking heat from the surrounding. The refrigerant temperature and pressure are kept at fixed value during the evaporation stage of refrigerant from liquid to gas phase. Now I have explained to you about the four elements required in the refrigerating device. Next is the basic flow of the refrigeration system. The flow is discharge from compressor, to receiver, to filter dryer, to electronic valve, to sight glass, to expansion device or expansion valve, to evaporator, to compressor suction. I will explain each part one by one. Now I will explain about the compressor. The compressor is like the heart in our body. It sucks the evaporated refrigerant vapor at low temperature and low pressure so that the evaporation would be easier. It compresses the sucked low temperature and low pressure vapor to high temperature and high pressure for easier condensation. The compressor also circulates the refrigerant. Next is the pressure gauge. The pressure gauge indicates the pressure. There are high pressure pressure gauge and low pressure pressure gauge. The high pressure side pressure gauge is calibrated for 0 to 30 kilograms per square centimeter, and the low pressure pressure gauge is calibrated for -1 to -8 kilograms per square centimeter. The refrigerant charge nipple is attached to the high pressure low pressure piping. It is essentially required for the use of manifold gauge during the leak test, vacuum test, refrigerant charge, and refrigerant transfer of the refrigerating device. Now I will explain about the condenser. The condenser cools the high temperature and high pressure refrigerant gas and makes it into liquid refrigerant. The heat discharged from the refrigerant gas charged to the condenser is the sum of refrigerating capacity sucked in the evaporator and the heat equivalent to the compression during the compression process. The condenser discharges this heat by transferring it to water or air. The refrigeration effect can be said to be bigger when the distance to the compressor is closer. Now I will explain about the receiver. The receiver takes the surplus refrigerant after it's circulated the refrigerating device. It temporarily stores the refrigerant liquefied in the condenser during the operation before it would be sent to the expansion valve. It is a high-pressure container. It also collects and stores the refrigerant when the refrigerating device is stopped. The service valve structure is shown in this figure. It is used for leak test, refrigerant charge, and air purge. The service valve controls the refrigerant transfer quantity by controlling the opening extent through valve manipulation. The service valve is used for installation of pressure gauge and leak test by using service port and closing valve, refrigerating device repair work such as refrigerant charge and air purge. Packing is used in the valve body so that there would be no leak. Adjustment of service valve is done by socket wrench and L wrench. It is attached to the compressor of refrigerating device using Freon refrigerant for use. Filter dryer. When there are moisture and impurities in the refrigerant system of refrigerating device, the refrigerating device receives bad impact. The filter dryer removes the moisture and impurities in the liquid line of the system between the receiver and expansion valve. Sight glass. The sight glass checks whether proper quantity of refrigerant has been charged or not. It is installed at the condenser or receiver side liquid line of the refrigerating device. The sight glass also checks the dryness of the refrigerant by color change. When the proper amount of refrigerant has been charged and the condensation state becomes good, the foam state will go away and the refrigerant will be in clear liquid state. It can be judged that proper amount of refrigerant is charged when there is foam but it does not move, when there is bubble at the entrance but there is no bubble at the exit, and when the foam is not continuous but is seen occasionally. Electronic valve. The electronic valve controls the flow of refrigerant by closing or opening by electric power. During the pump-down operation, it is connected to the temperature switch in series. The piping electronic valve opens or closes by the open or close of the temperature switch contact point, so that the pump-down operation can be done. Now I will explain about the cautions when installing the electronic valve. When the power would be supplied, the plunger escalation valve in the electronic valve shall be opened. Install a strainer just before piping and note the available voltage. If the power would be cut, the valve is automatically closed by the weight of plunger. If the refrigerating device is small model, use direct drive type. If the refrigerating device is big model, use pilot type electronic valve. When applying cable, the voltage should be checked again. There should be a space for the disassembly of manual device cap. The excitation coil should be at upper position. Installation should be vertical. Use for the adjustment of refrigerating device capacity, liquid surface adjustment of refrigerant, temperature control, prevention of liquid back, and flow control of refrigerant and brine. Please take caution so that the direction of arrow will not be changed. Now I will explain about the structure of electronic valve. Expansion valve. It is one of the important parts in the refrigerating device. It is also called as a pressure decreasing device because it decreases the pressure to make the high temperature, high pressure refrigerant liquid into low temperature, low pressure refrigerant. The pressure decreasing is done by throttling. Therefore, it is called a throttling valve or an expansion valve. The function of expansion valve. Decrease the pressure of refrigerant and control the refrigerant quantity in the evaporator. Control the pressure by supplying evaporator with low temperature, low pressure refrigerant liquid and vapor mixture by way of expanding the high temperature, high pressure liquid in the condenser through narrow line. The principle of expansion valve is same with the orifice. When liquid passes the cross-section that became suddenly narrower, like a nozzle or an orifice, the pressure decreases without exchange of heat or work with outside. Next is the caution when using expansion valve. If the opening of expansion valve is big, large amount of refrigerant will be charged to the evaporator. The refrigerant can be sucked into compressor without being evaporated and wet compression can happen. If the opening of expansion valve is small, the refrigerant liquid evaporates before it would arrive at the evaporator exit. If the refrigerant would absorb the heat again and become overheated, it can go into compressor and damage the compressor by overheating, discharge gas temperature increase, or cylinder overheat. Now I will explain about the capillary tube expansion valve. Capillary tube with very small diameter is used when supplying fixed amount of refrigerant in the refrigerating device like home refrigerator. The length and diameter can be chosen in the range of 0.6 to 6 meters in length and 0.7 to 2.5 millimeters diameter, depending on the refrigerating device. The valve is installed between the condenser exit and the evaporator to decrease pressure of refrigerant liquid. The valve is used when the refrigerating load, evaporation temperature, and condensation temperature are constant. The pressure becomes balanced when the device is stopped. Therefore, the compressor runs smooth when restarting. When the evaporation temperature would rapidly decrease, the specific volume of refrigerant increases and the refrigerant flow rate to compressor decreases. When the pressure difference becomes bigger, refrigerant quantity passing the evaporator is more than the discharge quantity of compressor. The liquid can get into compressor and there can be hammering. It is recommended to install receiver to avoid hammering. Next figure is the capillary tube installation detail. As seen in the figure, the pressure changes dependent on the length of capillary tube. Now I will explain about the evaporator. The evaporator absorbs the wet vapor, liquid and vapor, from the cooling objective that pass the expansion valve and make it into vapor phase. This part absorbs heat by the evaporation of refrigerant to cool the material, which is the objective of the refrigerating device. The intake wet vapor absorbs heat through the pipe wall from cooling objective and becomes vapor phase before it would be sucked to the compressor. Liquid separator or accumulator. If the refrigerant that had not completely evaporated in evaporator would be sucked into compressor, the compressor can be damaged because it should not compress refrigerant liquid that is not compressible. The liquid separator separates refrigerant liquid contained in the refrigerant gas before it would be charged into compressor. The liquid separator is a kind of low-pressure container installed at the suction pipe near to compressor. Liquid separator should be installed for the forced circulation refrigerating device or refrigerating device that have big variation in refrigerating load, mainly used in the ice-making warehouse or large capacity refrigerator. Now I will explain about how to use the temperature switch. It can be different depending on the manufacturer. Use of Set key. If it is pressed once, the temperature indicating window blinks. Please select required value by up or down key and press Set key once more to enter the selected value. The temperature value will automatically return to current temperature after 20 seconds. At this time, the set temperature would be automatically saved. Up-down key. When it is pressed continuously, the set value moves quicker. If it is pressed one by one, the value moves by step. HC key. You can choose heat or cool by choosing the arrow while pressing this key. Now I will explain about how to adjust the temperature switch. In order to maintain the temperature of evaporator at -15 degrees Celsius, the temperature deviation of digital temperature control switch is set at 1 degree Celsius. At -14 degrees Celsius, the temperature switch contact point will close, and the electronic valve of high-pressure liquid line will open. At -16 degrees Celsius, the temperature switch contact point will open, and the electronic valve of high-pressure liquid line will close. Pressure switch. An automatic control device is essential to control the state of a refrigerating device. It stabilizes the operation against the change in load and surrounding conditions. When there would be an abnormal pressure during the refrigerating device operation, the high-pressure brake switch or safety valve immediately returns the pressure to normal. It maintains the optimum operation of refrigerating device. It contributes in the economic operation of refrigerating device by automatic operation. An automatic control device that meets the operation of relevant refrigerating device should be definitely selected. Now I will explain about the structure of pressure switch. First is the low-pressure brake switch, which is a kind of pressure switch. This switch stops the compressor and condenser when the pressure of refrigerating device would go down lower than the setup value. When this switch would be used for compressor stopping purpose, it protects the compressor by stopping it when the pressure of refrigerating device would go down lower than the setup value. When this switch would be used for capacity controlling purpose, it controls the capacity. The contact point contacts, and it activates the unloader electronic valve and let the oil discharge to the inside of crankcase when the pressure of refrigerating device would go down lower than the setup value. Automatic recovery type is commonly used, which automatically recovers the original state after device activation. Next figure is the structure of low-pressure pressure switch. Now I will explain about the high-pressure brake switch among the pressure switches. It is a kind of safety device. It is set up about +4 kilograms per square centimeter higher than the normal high pressure. When the high pressure would go up more than a certain pressure, the compressor will stop by cutting out the power source of motor. HPS mainly indicates cutout pressure only. Next figure is the structure of high-pressure pressure switch. Now I will explain about the pressure switch adjustment method. When the evaporator temperature goes down lower than setup value, the temperature control switch opens. If the operation continues while the electronic valve is closed, the high pressure will go up and low pressure will go down. When the low pressure goes down lower than cutout pressure, the contact point of low-pressure brake switch opens. Then the compressor and condenser stop and refrigerating will stop. When the evaporation load increases and the evaporator temperature increases, the temperature control switch contact point will close and the electronic valve will open. When the balance of high pressure going down and low pressure going up, reaches the cut-in point of the low-pressure brake switch, the low-pressure brake switch contact point closes and the compressor, condenser will start up again for normal operation. Defrost timer, 24 hours. When the evaporator would be frosted, the refrigerating capacity will decrease due to the decrease of heat pass rate. Defrosting is required at this time. Defrost time automatically controls the defrosting time of electrical heat defrosting device and hot gas defrosting device together with the refrigerating device operation time on 24-hour basis. Manifold gauge. Manifold gauge consists of 2 gauges, 2 manual valves, and 3 separated refrigerant liquid lines. The manifold gauge is used in various tests such as leak test, vacuum test, refrigerant charging, refrigerant transfer, refrigerant recovery, and pressure measurement of various parts in the refrigerating device, dependent on its relevant purpose. It is also used to remove the non-condensed gas or air. Caution is required so that the low-pressure side, blue, and the high-pressure side, red, would not be confused and used incorrectly. Now I will explain about the arrangement of refrigerating device. First, we will fix the compressor on the table. There are various kinds in compressor, such as the centrifugal type, rotating type, vane type, scroll type, screw type, and reciprocating type. We use piston reciprocating type compressor in this test. This compressor has 3 protruding holes, 1 big and 2 small. The big hole is the compressor suction hole. The upper small hole is discharge, and the lower small hole is for the suction gauge or charge nipple. The compressor applies adiabatic compression on the low-temperature, low-pressure refrigerant gas sucked and makes it into high-temperature, high-pressure gas. It is an important process in the whole flow of refrigerating system. If there would be wet compression, the compressor can be damaged. Therefore, caution is required in the system configuration. After fixing the compressor on the table, the condenser will be fixed on the table. There are water cooling type and air cooling type in condenser. We use air cooling type in this test. The condenser exchanges heat between air and high-temperature, high-pressure gas from the compressor and liquefies it into high-temperature, high-pressure liquid. In other words, it makes the high-temperature, high-pressure refrigerant gas from compressor into low-temperature, high-pressure refrigerant liquid. After the fixing of compressor and condenser, the piping of compressor discharge and condenser part will be completed. Next, the receiver will be fixed on the table aligned to the bolt hole. The receiver temporarily stores the high-temperature, high-pressure refrigerant liquid from the condenser before it flows to refrigerating system. In order to have pure liquid flow to the refrigerating system, the gas exists in the upper part and the liquid exists in the lower part. The important role of receiver is that it stores all refrigerant when the refrigerating system has been stopped. It keeps the refrigerant during refrigerating device disassembly or operation suspension for a long time. When the whole quantity of refrigerant in the refrigerating system would be stored, it should not be more than 80% of receiver capacity, while the safe level is 60%. During the refrigerating system operation, the refrigerant capacity is about 20%. In the large refrigerating system, a pressure purge is installed to prevent the pressure increase in the receiver, which can be caused by gas generation by heat from outside, when the whole quantity of refrigerant would be stored in the receiver. This refrigerating system is a small one, therefore there is no pressure purge. When the receiver has been fixed, the piping at condenser discharge and receiver charge will be completed. Now we will connect the filter dryer. The filter dryer consists of dryer and filter. The filter removes the impurities in the refrigerating system that may have been generated during welding work. It also removes moisture in the refrigerant gas. There is dehumidifying agent, such as silica gel, in the filter dryer for the moisture removal of refrigerant. If a device has both dehumidifying agent and filter, it is a filter dryer. If the device has only filter, it is a filter. There are welding type and flaring nut type. Here, we use flaring nut type for reuse later. Then the piping at condenser discharge and filter dryer will be completed. Next, we connect the sight glass to the filter dryer. The sight glass is a kind of transparent window. Basically, the refrigerating system consists of piping, and it is not possible to look into inside. Therefore, the sight glass enables the monitoring of refrigerant flow and quantity in the line. There is color-banded litmus paper pasted on the inside of the transparent window. It is possible to know the moisture in the refrigerant because this color changes if there is moisture in the refrigerant. This is electronic valve. The electronic valve works on the power of electricity, as the name indicates. It is installed on the piping of refrigerating system. It blocks or opens the refrigerant flow in the piping. During the pump down or emergent operation of refrigerating system, it stops the system by controlling the refrigerant flow. The piping will be completed. Now we will fix the evaporator on the table. The evaporator takes the low-temperature, low-pressure refrigerant liquid from the expansion valve and cools or refrigerates it. There are air cooling type and water cooling type in the evaporator. The evaporator takes the low-temperature, low-pressure wet vapor or low-temperature, low-pressure refrigerant liquid from the expansion valve and exchanges heat with the air. The refrigerant goes into the compressor after it had been changed into gas state by removing the external heat. This is the expansion valve. The expansion valve takes the high-temperature, high-pressure refrigerant liquid and makes it into low-temperature, low-pressure refrigerant through throttling. There are temperature sensing type, manual type, and capillary tube type in expansion valve. The temperature sensing type again classified into internal equal pressure line type and external equal pressure line type. Here, we use external equal pressure line type. The piping of evaporator charge and expansion valve discharge will be completed. Next, we fix the liquid separator aligned to the table hole. The structure of liquid separator is similar to the receiver, However, the use method is different. The liquid separator should receive only gas, different from the receiver. Therefore, in and out are separated to charge the upper area gas only. It protects the compressor from wet compression. The piping of evaporator discharge and compressor charge will be completed. Next, we install the pressure gauge. There are high pressure part and low pressure part in the pressure gauge. With pressure gauge, it is possible to know the status of compressor. There are oil type and non-oil type in pressure gauge. It is calibrated inside so that the pressure at low pressure part and pressure gauge part can be shown during refrigeration system operation. Piping will be completed to the low pressure side of compressor charge and the low pressure side of compressor discharge. After pressure gauge is installed, the pressure switch will be fixed. The pressure switch controls the pressure. There are single type and dual type. If pressure goes down below setup value, the switch stops the compressor. If pressure goes up above setup value, the switch again stops the compressor. It protects the compressor and refrigerating system from high pressure and vacuum pressure. Piping will be completed to the low pressure side of compressor charge and the low pressure side of compressor discharge. As last, we install charge nipple. The charge nipple is a kind of gate to charge refrigerant or recover refrigerant at refrigerating system. It is the entrance or exit of the refrigerating system. Next will be vacuum work to create vacuum in the device. The word vacuum came from Greek, meaning empty. The extent of vacuum would be determined by the quantity of air that would be removed from the vacuum container. The vacuum status prevents the corrosion and oxidation of machinery and air. It lowers the boiling point of material so that they would evaporate earlier. It is possible to make the material transfer easier using absorption pad. It is useful to remove gas in the object and charge other material. It can be applied to industry with its electrical characteristics. Next is the sequence of vacuum work. Check the stop valve and electronic valve for open status so that the refrigerating device piping will not be blocked. Connect the service side of manifold gauge to the suction of vacuum pump. Close the low pressure side bypass valve of manifold gauge and open high pressure side valve. Open the service valve and expansion valve or receiver so that the refrigerating device will not be blocked. Start the vacuum pump using the switch of vacuum pump. Run the pump until there will not be any foam after the discharge side hose of vacuum pump is put into the oil container. When the refrigerating device becomes inside complete vacuum, close the high pressure, low pressure valves of manifold gauge. Vacuum drying should be done after the installation, disassembly, and repair of refrigerating device. Air has moisture, therefore air can block the line by becoming ice when passing the expansion valve. Air lowers the performance of refrigerating device and makes the motor be overloaded. When the device is completed, a leak test should be done to check the sealing of the refrigerating device. Following is the sequence of leak test. The service hose, yellow, of manifold gauge will be connected to a nitrogen container. The nitrogen pressure will be adjusted to the leak test pressure. Electronic valve and expansion valve will be opened so that there will not be any blocked part in the refrigerating device. The high pressure, low pressure manual valves of manifold gauge will be opened so that nitrogen will be charged into the refrigerating device. Wait until the nitrogen pressure will be generated in the refrigerating device and it reaches defined pressure when the nitrogen container valve and manifold gauge valve will be closed. Check for the existence of pressure decrease. After the leak test, open valve and discharge nitrogen. Next is refrigerant charge. When the air inside refrigerating device has been completely removed by vacuum pump, refrigerant can be charged. Close the low pressure side of manifold gauge and open the high pressure side. Open the valve of refrigerant bottle. Open the charge hose and the compression charge inlet valve for a moment and close so that the air in the hose would be removed. Open the high-pressure side of manifold gauge and close the low-pressure side. Open the valve of refrigerant bottle and charge refrigerant. Now I will explain about the correct way to charge refrigerant. The system is stabilized when the refrigeration charge quantity is proper. Overheated degree equals measured temperature of suction line just before the compressor. Temperature shown on the gauge, 5 degrees Celsius. Like in the figure, temperature of suction line just before the compressor equals 12 degrees Celsius. Temperature shown on the gauge equals 7 degrees Celsius, saturation temperature. In other words, 12 minus 7 equals 5 degrees Celsius. In this case, the overheated degree is 5 degrees Celsius, and it is normal. Overcooled degree equals temperature shown on the gauge minus measured temperature of liquid line, which equals 5 degrees Celsius. Like in the figure, temperature shown on the gauge equals 51 degrees Celsius, saturation temperature. In other words, 12 minus 7 equals 5 degrees Celsius. In this case, the overheated degree is 5 degrees Celsius and it is normal. Temperature of liquid line just before the expansion valve equals 46 degrees Celsius. In other words, 51 minus 46 equals 5 degrees Celsius. In this case, the overcooled temperature is 5 degrees Celsius and it is normal. This is the case when too much refrigerant had been charged. The gauge temperature equals 51 degrees Celsius. Temperature just before the expansion valve equals 43 degrees Celsius. In other words, 51 minus 43 equals 8 degrees Celsius. In this case, the overcooled degree is 8 degrees Celsius and too much refrigerant had been charged. The lower part of condenser is filled with liquid, and full liquid refrigerant is overcooled by 3 degrees, overcooled. The refrigerant should be discharged until the temperature would reach 46 degrees Celsius. This is the case where too little refrigerant had been charged. Temperature of suction line just before compressor equals 16 degrees Celsius. The gauge temperature equals 7 degrees Celsius. 16 minus 7 equals 9 degrees Celsius. In this case, the overheated degree is 9 degrees Celsius and too little refrigerant had been charged. The evaporation had been finished at the rear part of the evaporator. The refrigerant became gas state and the rear part had been used as suction line, not for heat exchange. The gas refrigerant gets more heat, overheated, by 4 degrees Celsius. Refrigerant should be charged more until the thermometer would reach 12 degrees Celsius. Now, I will explain about refrigerant supplementation when refrigerant charge was not enough. Evaporator that is partly frosted. Pressure decrease in the low-pressure side. Leakage in the refrigerating device. Refrigerant should be supplied when the operation of refrigerating device was excessive. Next figure is the flow of refrigerating device. The flow is discharge from compressor, to condenser, to receiver, to filter dryer, to electronic valve, to sight glass, to expansion device or expansion valve, to evaporator, to compressor suction. These are diagrams for each part as seen in the PI linear diagram. As seen in pH linear diagram, compressor. Condenser. Expansion valve. You can understand by identifying it as the evaporator. In the figure, the pressure is a line shown on the horizontal line. The pressure on a single line are all same for the zones of overcooled, wet vapor, and overheated vapor. Like in the figure, the pressure of refrigerant is calibrated in the vertical axis. Therefore, the refrigerants on the isobaric line have same pressures. The pressure is the absolute pressure, which is gauge pressure plus atmospheric pressure, kilograms per square centimeter. In the figure, the enthalpy is the line on the vertical line. Enthalpy is the sum of the internal energy and the work energy. It is the sum of all calories contained by the refrigerant in certain states. For instance, If the enthalpy is 200 kilocalories per kilogram, that material 1 kilogram has 200 calories. Enthalpy of 0 degrees Celsius dry air is 0, and the enthalpy of 0 degrees Celsius saturated solution is 100 kilocalories per kilogram. It is possible to calculate refrigerating effect, QE, condensing calories discharged, QC, and required power, AW. Here, the refrigerating effect can be calculated as compressor charge enthalpy minus evaporator charge enthalpy. The condensing calories discharged can be calculated as compressor discharge enthalpy minus expansion valve charge enthalpy. The required power can be calculated as compressor discharge enthalpy minus compressor charge enthalpy. Now I will explain about the saturated liquid line and saturated vapor line. The saturated liquid line is, as seen in the figure, the saturated liquid line is the curved line drawn from the left bottom to right top until critical point. The refrigerant state that is going to evaporate immediately is on this curve. The left of this curve is overcooled liquid state that has lower temperature than saturated liquid. The right of this curve is mixed state of liquid and evaporated gas. In other words, it is the state of wet saturated vapor. The saturated liquid line is calibrated for the saturation temperature that corresponds to the pressure. The saturated vapor line is, as seen in the figure, the saturated vapor line is the curved line drawn from the right bottom to right top until critical point. The refrigerant on this curve had already finished the evaporation. Therefore, it is dry saturated vapor without any liquid. The temperature of refrigerant is saturated temperature like the vaporizing liquid. In the figure, the left of this curve is wet air state where liquid and vapor exist together. The right of this curve is overheated vapor higher than saturation temperature. The refrigerant vapor in this zone has higher temperature than the liquid that evaporates under same pressure. The critical point. The intersection of saturated liquid line and saturated vapor line is the critical point. The pressure and temperature at the critical points are the critical pressure and critical temperature. The critical temperature is the highest temperature at which any gas can be condensed. Next is, now I will explain about the isothermal line. This line is made by connecting the points having same temperatures. The temperatures on the isothermal line are all the same. The left part of saturated liquid line, in other words, the isothermal line, showing the liquefied refrigerant, is almost identical with the isoenthalpy line as seen in the figure. The isothermal line and the isoenthalpy line cross with each other at right angles in the overcooled zone. In the wet vapor zone, they are parallel. In the overheated vapor zone, they come down in a steep slope. Like this, it is possible to know the evaporation temperature, condensation temperature, suction gas temperature, and discharge gas temperature from the isothermal line. Now I will explain about the isoentropy line. As seen in the figure, it is the line drawn upward in oblique to the right direction. The entropy of certain object does not change when there is no entrance or exit of heat. If the refrigerant gas compression in the refrigerating device compressor is assumed as an adiabatic compression, the entropy of the refrigerant vapor does not change. However, the pressure, temperature, and specific volume of refrigerant does change along the isoentropy line. The isoentropy line exists only in wet vapor zone and overheated vapor zone. The compression stage is regarded as an adiabatic compression in theory. Therefore, it goes on along the isoentropy line. The entropy of 0 degrees Celsius saturated solution is 1. Now I will explain about the isospecific volume line. The isospecific volume line is made by connecting the points at which the specific volumes, volume of 1 kilogram refrigerant, of the refrigerant are the same. As seen in the figure, the isospecific volume line is drawn in a dotted line in the wet vapor zone and overheated vapor zone. For instance, If the specific volume is 0.2 cubic meters per kilogram, the isospecific volume line means the refrigerant that has 0.2 cubic meters volume for each kilogram. The isospecific volume line exists only in wet vapor zone and overheated vapor zone. It is possible to know the specific volume of sucked vapor from isospecific volume line. Now I will explain about the iso-dryness degree line. The iso-dryness degree line shows the section between saturated liquid line and saturated vapor line in 10 equal parts. Respective dryness is shown along the iso-dryness degree line. Here, x equals 1.0 means dry saturated vapor. X equals 0.0 means saturated liquid. And x equals 0.3 is dry saturated vapor with 30% moisture and remaining 70% saturated solution. The iso-dryness degree line exists only in wet vapor zone. It is possible to know the quantity of flash gas from iso-dryness degree line. Up till now, I have explained to you about the PI diagram. Please draw the refrigeration linear diagram yourself after getting the data from the refrigerating device you had completed during the training practice.